Good morning, students. So this is a second video on the same chapter, physical quantities and measurement. In the previous video we have learned what is density. So density depends upon arrangement of particles. In the previous video we have learned, you see there were two boxes. Here arrangement of particles were very close to each other, and here the particles are far away from each other. In a unit area, the number of particles is more than that of second box. So we say this box, that left hand side, box A, is more denser than that of box B, which is in right hand side. So density is defined as mass per unit volume, that is mass of substance present in a given volume. Okay, it is the basic characteristic of a substance that explains the relationship between its mass and volume. It determines how tightly the molecules of an object are packed into a given amount of surface space. So here in the box, the number of particle in an unit area, if I consider only this portion, you see 4 poles are there in the lower most corner, but here we have only 2. That means number of particles is here less, so it is less denser than this. Okay, so this was density. Now next point comes how to determine density of any material. To calculate any density of any substance, we need to calculate first its mass, then its volume. After calculating its mass and volume, we can calculate its density. So mass can be expressed in kilogram and volume can be expressed in meter cube, that means kg per meter cube, that is the SI unit. Whereas CGS unit is gram per centimeter cube. If you express mass in gram and volume in centimeter, then we will be getting gram per centimeter cube. Okay, so this all we have learnt in the previous video lesson. Also we have come across the different volume formulas for rectangular block, cube, cylinder, sphere. Rectangular block, when I say, that is called cuboid, like the shape of your geometry box. It is length into breadth into height. Similarly cube, all the sides are same, so side into side into side. Cylinder formula is pi r square into height, where r is radius, and we know half of diameter of any circle is called radius. Similarly volume of sphere is 4 by 3 pi r cube, where r is the radius here. Also you see in your screen beam balance. This beam balance we use to measure the mass. In order to calculate density, first we have to find mass, then volume. So mass of any substance can be calculated by beam balance. Eureka can. So this Eureka can, it is used to find the density of an irregular solid. If there is one stone and you need to calculate the density of any stone, that density of stone can be calculated by using this Eureka can. So Eureka can is nothing but a container, first whose mass is to be measured. We will measure its mass. Let us consider that will be m1, or let it be m. Mass of this container is m. This one we will measure by beam balance, right? Then what we will do, we will put liquid, let us consider water, up to neck. As soon as it gets filled up, that is overflowed, so up to that level completely will fill it with water. Then we will tie the solid whose density is to be found with a string. Then that string joined with stone, we will dip inside this container. When we will dip the stone here, the water will come out, the water will get overflowed here. That water is connected in another vessel. Now in the third step, we will measure the mass of this jar along with water. Okay, so first what we have done, we have calculated the mass of an empty jar, then we filled with water, completely filled, then we dipped the solid tying with a stone, then we will measure again that mass. Let us consider that mass to be m2. So m2 minus m1 will give you mass of the liquid inside the jar, and that mass of the liquid inside the jar is the volume of the stone. So we know the formula, density of any stone equals to mass by volume. So what is the mass? Mass was m and volume m2 minus m1. So this is how we'll calculate the density of the solid by using the Eureka can, which I have already explained in the previous video lesson. Okay, so here you see there is one example also, one numerical. A stone is immersed in a Eureka can. The mass of the empty beaker into which water overflowed was 30 gram, and the mass of the beaker with the water with the Eureka can is 56 gram. So the empty Eureka can, what is the mass here? 30 gram. But when you filled with water, what is the mass here? 56 gram. If the mass of the stone is 87 gram, what is the density of the stone? So you see, stone mass is given, but stone volume we have to calculate. So to calculate the volume, that is why we will find m1 and m2, then we will subtract that one. That is, m1 is given 30 gram. That means when the beaker was empty, and when you filled with water, it became 56 gram. So 56 minus 30 is 26 gram, which is the volume of the stone. Okay, so volume we know 26 centimeter cube. Mass already we know, that is 87 gram, it is given in the question mass. Now we want to calculate the density. The formula is m by m2 minus m1. M is 87 and m2 minus m1, that is 26. So we will divide this one. So this was in gram and centimeter cube, but if you need to convert to kg per meter cube, from gram per centimeter cube, if you need to convert to kg per meter cube, then we have to multiply by 1000. Whatever answer we got, that one you multiply by 1000. Now if point is removed, 3 zeros will be coming down, so 3 zeros and 1000 will get cancelled. So what we will get? 3346, that means 3346 gram per meter cube. Okay, so this is how we calculate density of any solid whose volume is not fixed. We can also calculate density of an irregular solid, that is stone, by using this measuring jar. Measuring jar has one advantage, that it has marking. It is graduated. Okay, you see 50, 100, 150, like this markings are there. So first what we will do, we will fill with water, then we will dip a stone. You see in the diagram, a stone is dipped. So when you dip a stone, the level of the water will rise up. Then we will subtract the reading, previous reading, that means where the previous water was. Now after dipping the stone, now where is the final reading of that water? So if we subtract, then we will get the volume, right? So after calculating volume, because we know the mass of the stone is m and volume is V2 minus V1. V1 is the initial reading of water and V2 is the final reading of water after dipping the stone. So density, again we know mass by volume, so mass by V2 minus V1. So this is how we calculate the density of any irregular solid by using a measuring cylinder. So there are different types of measuring cups and measuring can, you see. In our day-to-day life, we often come across this. It's any oil shop where they keep kerosene or petrol for the vehicles. We know this is a measuring jar. Okay, so they are calibrated, that means they are graduated. That means it is available in 100 milliliter, 500 milliliter, 1 liter, okay, or 3 liter or 2, 50 milliliter. So like this, different capacities of jar is available in the market. So this one we use to measure the volume of liquid. So this type of jar are also available. They are available in 50 milliliter, 100 milliliter, 200 milliliter, 500 milliliter and 1000 milliliter. When a jar contains water, suppose this is a jar, now if you fill it with water, then the water won't be a straight line, it will be curved. Either the curve will be like this, that is it is called convex, or the curve will be concave, that means upward. You see, the water is sticking up. Either it will be convex, this is the convex shape, and this is the concave shape, right? So we have to draw an imaginary line. Imaginary line means imaginary vision perpendicular to the water level. Let us consider the lower portion is 20.4 and upper portion is 20.2. So we will be taking 20.3. Okay. So this curved surface is called meniscus. Okay. So what is meniscus here? It is an imaginary curve which is drawn through the level of the liquid. You see here, this is the meniscus. So this curved path is called convex meniscus, this is called concave meniscus. Okay, so we will be taking an imaginary line. Did you see a vertical line, a horizontal line here? So which gives 20.3. So there are few conversions from kg per meter cube to gram per centimeter cube. We know 1 kg is equal to 1000 gram, and 1 meter cube, when I say, that means 1 meter into 1 meter into 1 meter, that is 100 into 100 into 100, that means you see 6 zeros, that means 10 lakh centimeter cube we called it as, right? 1 kg per meter cube equals to 1000 by 6 zeros, because you see 1 kg is 1000 gram and 1 meter cube is there, 6 zeros are there. Similarly, if I write 1 kg by meter cube, that means 1000 gram by 10 lakh. So if you cancel, you will be getting 1 by 1000, or if you cross multiply, you will get 1 gram per centimeter cube equals to 1000 kg per meter cube. So directly this value we will be using, like in the previous numerical we had in gram per centimeter cube. If we need to convert in kg per meter cube, then we need to multiply by 1000, right? 1000 kg per meter cube. And conversely, if it is in kg per meter cube and the question is asking to convert in gram per centimeter cube, then you will divide by 1000. So to calculate the density of any irregular solid, we may be using Eureka can, we may be using here measuring jar, or we will be using some other method. But to calculate the density of any liquid, we will be using density bottle. So density bottle is used to measure the density and relative density of a liquid. Okay, so density bottle looks like this. Okay, it has a ground glass stopper which has a hole up, and a stopper is being immersed, a glass stopper is being immersed inside through the hole. First, how does it work, you see? So to calculate density, we must know what is its mass, then what it is volume. If we know mass and volume, then easily we can calculate the density. So mass of the bottle, first it is calculated by the beam balance, and let us consider that mass to be m1. Now the liquid whose density is to be calculated is to be poured inside this bottle. We have to pour that liquid. Suppose you want to calculate the density of petrol. So first we will measure the empty bottle mass, then we will pour petrol. After pouring petrol, then you see this stopper, we will immerse through the hole. Now when we immerse, the extra petrol will come out. Okay, So this will make an uniformity. That means whatever liquid we place inside, excess liquid will come out, and this bottle will hold only a fixed amount of liquid. Then we will measure the mass of the density bottle contained with that liquid, unknown liquid, whose density is to be found. When we have placed petrol here, then we place the stopper, that extra liquid came out, then we will measure that density bottle containing petrol, right? So after calculating, after placing the stopper, then we will measure its mass once more. So let us consider that mass to be m2. Okay, so when it was empty, the mass was m1. When you filled with that unknown liquid, the mass became m2. Now if we subtract m2 minus m1, then we will get the mass of the liquid, and volume is fixed. The volume of the liquid, unknown liquid, is the volume of the container, because that liquid atoms will take all the space of the jar. That means volume of the liquid is equals to volume of the density bottle. So what is the formula? Density is equal to mass by volume. Mass means m2 minus m1 by volume. So this is how density can be calculated by using density bottle. Next topic we have relative density. Relative density, that means density of any substance, we calculate by comparing with one standard liquid. Let us consider that standard liquid is water. Okay, so we know the density of water is 1 gram per centimeter cube, that is fixed. Now when I say 1 gram per centimeter cube, that means 1000 kg per meter cube, and density of iron is 7870 kg per meter cube. Now if I need to calculate the relative density of iron, that means density of iron by density of water, so that is 7.8. So this is how we calculate the relative density of any substance. In the simple words, suppose if I need to calculate the density of any solid, suppose this one, this duster, then I will be comparing its density with any other density, standard density. So similarly, if here this density of iron is compared with the density of water, and if I calculate the density of this duster here, then I have to divide by 1000 kg per meter cube. That means I am comparing the density of this duster with water. Then this is the relative density of a duster. So this is the meaning, that relative density of a substance is the density of that substance compared to the density of water. It tells us how dense an object is when compared with water. So it is less denser than water or it is more denser than water, that can be easily found out by this relative density. But remember, the density of water which we are calculating, that has to be at 4 degrees Celsius. So this is the formula: relative density of a liquid, density of liquid by density of water. So density we know, mass by volume, that means mass of liquid by mass of volume of liquid, divide by, you see divide sign is there, mass of water by volume of water. Okay, as the volume of liquid and volume of water will be same, that means they will get cancelled up. So the relative density of liquid equals to mass of liquid by mass of water. Mass of liquid means m2 minus m1, and mass of water means m3 minus m1, where m1 is the mass of empty jar, m2 is the mass of the liquid when the jar is filled with that liquid, unknown liquid whose density to be calculated, and m3 is the mass of that jar containing water. This was the empty mass. So m2 minus m1 by m3 minus m1 will give you the relative density of that liquid. Next topic we have sinking and floating. Some object float on the fluid, some object gets sink. Let us consider a vessel containing water. Above that water surface, if you place thermocol, then thermocol will float. Similarly, if in that same of water, if you place a duster, then duster will sink, because the density of duster is more than the density of thermocol? Simple. So there are various examples by which we can understand that which substance is getting floated on the surface of water or floated on the surface of that fluid, or which substance is getting sinked. Wood floats on water because it is less dense, whereas steel pin sinks because it is denser than water. So if you place a wood, then it will float on the surface of the water, but if you place a steel pin, then it will sink because steel pin is more denser than that of wood. Similarly, a nail sinks in water because it is denser than water, and it floats on mercury because it is less denser than mercury. That means iron is less denser than mercury. Mercury is more denser. Kerosene or oil floats on water as water is denser than oil and kerosene. So whichever object whose density is less will be floating up, and if the density is more, then it will sink inside. Okay, the density of ice is less, so it floats on the surface of water. So in the screen you can see one ship which is floating on the ocean. You see, the ship is made up of iron, but it is not sinking inside the ocean. But whereas if I place a huge mass having the same mass of that ship of iron directly on the ocean, then it will sink inside. Now what is the reason that a iron nail sinks inside the liquid but a ship made up of iron is not sinking? The answer to this question is that the ship is hollow from inside. You see here inside it is hollow from inside, then water will take at that hollow space, and relatively the average density of that ship gets decreased. Due to decrease in average density, the ship is not sinking inside the water. Okay, so that time the density of that ship becomes less than that of water, and we know if the density of an object is less than that of fluid, then it will float. So that is why the ship floats. So also we know that it is easier to swim in fresh water than that of sea water. That means it is easy to swim in river than that easy to swim in this sea water than that of river, because sea water is the saline water, the density is more, so it will exert more force in upward direction, so it will help us to float in sea water rather than that of fresh water. Yeah, this is the question which I was talking about. Swimming in sea water is easier in fresh water because sea water provides a greater upthrust as compared to fresh water. Upthrust means force in upward direction. Because the density of sea water, which is saline, is higher than the density of fresh water. For the same reason, when a ship enters a sea water from a fresh water, it sinks less, as sea water being dense has more upthrust. That means when the ship was in sea water, suddenly when it went to fresh water, it sank, because in sea water it was floating because the density of sea was more, but when it went to the fresh water, density became less. Density of the liquid became less and the ship became heavy, so it gets sink inside. So hot air balloon also works on this principle. So here you see in the basket of that parachute, which allows this parachute to rise up. Generally we know solid, liquid and gas, it expands on heating. When we heat solid, the expansion is very less as compared to liquid and gas. When this parachute air is heated up, the hot air density, due to its less density, it rises up and makes this parachute to move in upward direction. Not only here, we also know that bottom of a swimming pool, generally it feels more colder than the surface of the water. The hot water always it floats in upper position, than that of cold water. So this is the reason warm water being light floats on the cold water. So this process is known as convection. That means hot particles moves from one region to another region, that is from hot place to cold place, and relatively it density gets decreased. Okay, so same thing we see here in the hot air balloon also. It is based upon same principle. So this is the end of the chapter. So the last topic which we see here, that is comparison of densities of solid, liquid and gases. So in solid, here you see molecules are packed closely together. Solids are so compact that their shape and volume are fixed, so any substance in the solid state is more dense as compared to liquid and gas. In the liquid and gases, we see the particles are far away from each other, due to which its density is less as compared to that of solid. In your WhatsApp group, I will be giving the exercise questions of this chapter, so you need to write this one also. Okay, you see the exercise questions, short answer type questions. Here this chapter question answer you will be searching from the exercises. Here I will be giving the notes of the chapter also, so you will search the answers and you will note it down in your exercise book, okay, in your copy. Okay, and in this coming week I will be taking some online classes, online test on the previous chapter. Make sure that previous chapter is completed. So very soon I am going to conduct on online test, so you will be notified of first chapter.